Hi everyone, myself Jyoti Prasad. I'm going to discuss about data acquisition from IoT sensors and actuators in robotic system. So, if we are going to see the data acquisition in with respect to IoT or with respect to IoT applications in robotics, so it is the main part. Later on, the data can be processed using filtering, aggregation, and normalization. Even though this data processing techniques is the further one, the basic primary thing is first to acquire the data using data acquisition methods. So using sensors or actuators. So basically, data acquisition can be done using in robotics using many sensors like motion sensor, temperature sensor, light sensors, and actuators convert the signals into mechanical action. What are the sensors in robotics is nothing but you can have an idea by seeing this picture. Many sensors are there, few of them can capture the vision. We have them positionally are sound-based sensors, speech-based sensor, touch-based sensors, and communication sensors. And few of the things will focus the sensors. Smell, what are all the gases can be detected, and pressure, what are all piezoelectric sensors which will feel the pressure of the particular environment. Electric taste, even though some high-end industrial sensors produces the taste sensing also. So the elaborated explanation for each sensor has been given in this slide. Vision, which is a CMOS image sensor and IR sensors, infrared sensors. So this will captures the images objects with depth and human eyesight. Positioning means based upon the robot's orientation, moment, and spatial positioning, it will read the data or sense the data. Sound based upon microphones and audio sensors, allowing it to recognize the voices and detect the noise types, any background noises or any external noises or intruders based upon that noises. And interact via speech recognition also can be done as a future extension. Speech using microphones and these touch, force, and haptic sensors. Whereas coming to the gas sensors and odor sensors, which will smell the dangerous gases or hazardous gases. So we can also feel the pressure of a particular objects using pressure sensors. So if you see the types of sensors based upon the based upon the type, is based upon the category, we have category based upon the application also. We have categories into environmental sensor, positional sensors, proximity sensors, visual vision, tactile, and motion sensors. So where we are using these data acquisition, many areas. So eyelid actuators. So far we have seen the sensors in data acquisition. Now we are going to see the actuators in data acquisition. Eyelid actuator. So eyelid actuator means it controls the movement of eyelids, enabling the robot to blink or express the motions. Neck actuator, arm actuator, so and speakers based upon the action or based upon the command, it will speak using voice interaction. So if you see the types of actuators, electrical motors, linear actuators, air muscles, grippers or manipulators, and hydraulic actuators. So if you see the data acquisition, first the data should be collected using environmental or based upon the surroundings, position or operational data. That data will be transmitted via IoT protocols like Bluetooth, Zigbee, Wi-Fi, and that data will be processed and analyzed. And based upon that commands for actuators, the action will be executed. So these are all the step-by-step things will be executed based upon the data acquisition done by robots. What are the components of the data acquisition system is nothing but sensor, signal conditioning, data loggers, analog to digital conversions, and an interface system between the computer and data transfer. Also, we need additional devices like power supply, software, communication protocols like MQTT, and calibration standards, real-time RTC, real-time clock, data compression, etc. And if you see the types of data we are getting, or we are recording the data, What are the type of data is nothing but temperature, humidity, light intensity falls under environmental data, and location, orientation, GPS position all comes under positional data, or any obstacle in front of a particular object or our robot. So that comes under as an obstacle. That is proximity and distance data. High resolution images and videos comes under vision data, and the last one, force and torque data, becomes from safe and precision manipulations.